within the area, every router in OSPF know each other and what the links they are advertising. So whenever, let's say, I enabled OSPF on the loopback 4, on R4 on the loopback 0 here, and that network 4444/32 will need to be advertised as the network running OSPF towards R5, and that is something we're going to look at here. So what is formed between them upon synchronizing databases is the link state database, and within the area there would be typically two types of OSPF link state advertisements. LSA type 1, known as a router LSA, and LSA type 2, known as a network LSA. LSA type 2 network LSAs are generated by the pseudo router designated router on the segment here. So let's take a look at the database here between R4 and R5 and see what we're learning from that. The command will be show IP OSPF database. So this is what R4 sees about the world in area 0. It sees that there are two routers advertising LSA type 1, which describe the links, addresses, and their relationship to the rest of the network. What that relationship we will see in a second. And there's definitely one DR discovered in area 0. Its router ID is 5555, and its link connected is 10.145.5. So if I do show IP OSPF, let's say, and this is the database with the extra keyword, there's a bunch of keywords if you do question mark here. I want to look at the router LSA, which describes LSA type 1. Link description of every router. So let's start with me. So what I see about the world, so link ID and the route ID is the same, so I'll say 4444. I need to add the router keyword, of course. So once I say router keyword here, this is information about, this is router 4444, process ID 1, and link state LSA type 1 in area 0. This is the age timer, a bunch of things, link state ID, advertising, router, and so on and so forth. Number of links 2, which is actually already showing here. So this is indication that the router 2 is advertising 2 links running OSPF, and it's a loopback and Ethernet 0045. So let's see that. The loopback is manifesting itself with a metrics cost. We'll talk about cost later. 1, and its address is 4444 and /32. Just a side note, loopbacks, irrespective of their actual net mask, will always be presented in OSPF by default with /32. This can be changed, but no need for that at the moment. More importantly here, apart from the link address mask, it says that the relationship of that interface towards the rest of a network is stub network. That means it's a dead-end street, it's a cul-de-sac, it's a leaf network. There is no other router out that interface that is running, a router that is running OSPF. There's also another link it advertises, and its relationship is to a transit network with a cost of 10, and the router link interface is 10.145.4. So this is the transit network. The transit network might have here, and it does in fact, a neighbor. That's why it's transit. That means there's not just a me on that transit network, but there's somebody else. Who is there discovered? Well, we know that there's a representative of that network that is distributing LSA information called a designated router, and that one has a link address 10.145.5. So we could now inspect, and in fact it's showing right here. This link ID is showing here, and the advertising router is 5555. So we could now ask, what does this link or designated router on that link know about other routers existing on that transit network? Well, we do the show IP OSPF database, and it will say network. Now we're asking LSA type 2 because this one is advertising everyone knows about that network. We say 10.145.5, and it says, okay, I am a designated router, and on that transit network, I discovered two attached routers. So this is 5555, that will be me. And how do we know that this is the designated router? Because we see this here, advertising router, right? We see this also here. And link state ID is obviously 45.5. And I discovered one router which is 4444. So if I want to see what other networks this designated router is connected to, I would say go back here. This is my 5555, and I could ask, okay. So what it says, by the way, before we do that, it says, hey, on that transit network, the link is 10.1.45.5. Mask is 24 on that transit network, so this is a /24. All these networks are /24 here. I discovered two routers. Myself, well, let's go back here. Myself and router 4 on that transit network /24. So if I say, okay, so what are the show IP OSPF database, what are other networks R5 is advertising, and I will say router and 5555. So router is LSA type 1, describing the links and their relationship to the network. It advertises only one link. Number of links 1, which we saw also here at the very beginning, right here. And that link is this link towards the transit network. So that way OSPF builds the topology tree. Now the question is, what would happen if R5 started to advertise maybe that network, but didn't discover any router here? Let's do that. So something's going to change. I'm going to enable OSPF on this E024 interface. And I'll do it with a interface-based command. So I'm going to go to interface E02, what was that, 224. I'll say IP OSPF process 1 area 0 as well. Once enable that, do show IP OSPF interface brief. It starts sending hello packets. Wait timer is 40 seconds to discover designated router. If we don't, this one will become a designated router on that broadcast network. So when I now go back to my R4, let's clear the terminal maybe on R4 to get clean output. If I do show IP OSPF database now, I'll see that 5555 is now advertising two links. So if I ask what are, obviously nothing changed in terms of transit network. There's still, show IP OSPF database, the network LSA with advertised by 5555. 10.1.45.5 on that link. We have two guys. But if I ask the same guy, 5555, for its router LSA type 1, I'll see now it's advertising two networks, stub network 10.1.40 and transit network. So the question is, why is it the stub network, not the transit network? The reason is because there was no other router discovered. That's why it's a dead-end street. So its shortest path calculation algorithm only calculates paths towards those the networks, and the networks themselves are not being calculated. The cost is just added. So now we have two transit. If I did enable a router here, let's just go do this for fun. I'm going to go to switch 3, and this is a VLAN 4, so I'm going to say a router OSPF 1. Router, actually, it won't start because first I need VLAN 4, at least one IP address on that one. Now the 4, let's make it 100, 255.255.255.0, no shot. So do ping 10.1.4, and the address should be 254. So I should be able to ping it. Okay, and I can now in one shot enable both process and OSPF on that interface. I'll say IP OSPF 1 area 0. This will do both, enables the routing process in the global config mode and it starts the OSPF on that VLAN 4 interface. Now loading full. So now we have the adjacency here. So if I go back to my R4, show database, I have a presence of another segment and another designated router with this address, which by the way is the same physical box advertising that designated transit network. However, if I ask show me the networks, the LSA type 1 advertised by this guy, now there's two transit networks showing. So that stub network previously here changed into transit as there is some other guy on that link. And we could also ask, okay, so who's on that link? Show IP OSPF database, and we would say network, let's say type 1 advertised but on that link, which is 10.1.4.254. And we'll see two routers now. It's a router 5. So network is /24. This is the link address. So 10.1.4/24. And I discovered two routers attached to the network. Myself and this guy, which is the switch 3. And that's the way the system creates a database in OSPF routing protocol within a single area. Each router knows all the connections and the addresses and builds the routing table. So at this point, show IP route OSPF, third database, I see how to reach the 10.1.4.0 network. Similarly, 5 knows how to reach the loopback of R4. Do show IP route OSPF. It knows how to reach that loopback interface outside this interface.